The best agent architecture is sometimes no agent at all. Claude agents are powerful when tasks require uncertainty. They excel with tool selection and iterative revision, but many production workflows need predictability more than autonomy. CCA candidates must learn restraint, choose deterministic systems when the path is known, when the risk is high, or output must be repeatable. The bottleneck isn't capability, it's control. Agentic systems add planning, tool loops, and memory. They include retries, context growth, and stopping logic. Existing agent everywhere approaches fall short. They treat every task as open ended. In production, unnecessary autonomy increases latency. It raises costs and debugging complexity. Unpredictable behavior becomes more likely. If a workflow has fixed steps, it doesn't need reasoning loops. Fixed rules and data sources mean no need for dynamic decision making. Password resets work better as deterministic pipelines. Invoice formatting can be handled without agent loops. Ticket routing benefits from predictable, rule-based processes. Report generation is more efficient with fixed workflows. Status notifications should follow set patterns. Claude can assist inside the pipeline, but it shouldn't dynamically control the entire process. The breakthrough is seeing determinism as product quality. It's not a technical limitation, it's a feature. A predefined workflow gives teams clearer tests. It ensures stable outputs every time. Execution becomes cheaper and more efficient. Compliance gets easier to manage when the business knows the correct path. The architecture should encode that path directly. No need for Claude to rediscover it each time. A workflow orchestrates LLM calls and tools through predefined code paths. The system determines the sequence, branching, and validation rules. It also defines when a task is considered complete. Claude can summarize, classify, extract, or draft information, but the code maintains control over the entire flow. This pattern works best when repeatability is more important than exploration. It ensures failures are handled in a predictable and consistent way. An agent is justified when the next step depends on evidence. Research, debugging, and multi-step investigations often require planning. Code-based exploration and customer issue diagnosis need observation. Complex tool use demands that Claude act, observe, and revise. The key question: does the system know the path up front, or must Claude discover it through exploration? Do not use autonomous agents for irreversible actions. Sensitive tasks like refunds need strict controls. Account deletion requires human approval. Medical advice must be reviewed before acting. Legal decisions should never be automated. Payroll changes need validation. Production deployments require gates. Customer-facing messages need oversight. Claude can recommend actions safely. Backend code checks permissions first. Humans approve final consequences. Agentic systems can fail gracefully even when incorrect. They might call the wrong tool by mistake or misinterpret an observation entirely. They could retry a flawed plan repeatedly. They may stop too early with high confidence. Deterministic workflows show failure more clearly. Each step has expected inputs and outputs. Errors become obvious in structured processes. Visibility often matters more than intelligence. Choose deterministic workflow for repetitive tasks. It's regulated, cheap to specify, and easy to test, sensitive to variance. Use deterministic workflow. Choose an agent for open-ended tasks. Evidence-driven, tool-dependent, hard to predefine. The mature architect doesn't ask if Claude can do it. They ask whether Claude should control it. The strongest production systems combine both patterns. A deterministic workflow handles authentication and routing, manages validation, logging, retries, and approval. Claude handles language understanding and extraction. It supports reasoning and drafting within bounded steps. This hybrid design captures AI flexibility without surrendering system control to open ended loops. Test the agent against a simpler workflow, compare accuracy, latency, and cost, evaluate traceability and recovery behavior, assess user trust in both approaches. If the deterministic version performs similarly, keep it. Fewer moving parts mean less risk. Complexity must earn its place. An impressive agent that underperforms is architecture theater. Autonomy is a design choice, not a default. Use agents when uncertainty demands adaptive reasoning. Use workflows when the path is stable. The future of reliable Claude systems belongs to architects. They know when to add intelligence. They know when to constrain it. They know when to leave it out entirely.